Greetings everyone. My name is Dipankar Kalita, Research Scholar, Department of Physics, Northeastern Hill University, Shillong, Meghalaya. The title of my presentation is Range of 7.7 to 18.0 volt MeV per nucleon 93 niobium in Makrofol-E detector. Our main area of research in the field the solid state nuclear tech detector. Everywhere it is called the SNGTs, which is basically tech for nuclear radiation and many applications in various fields of science and technology like the biomedical research and space research, etc. People are use solid state nuclear tech detectors because it has simplicity, low cost, low weight and high efficiency and durability than other detectors. As we all aware that this field was started by the D.A. Young in the year 1958. He observed that the fission fragment takes in the lithium fluoride crystals. In 1960s, the three scientists R.L. Fraser, P.B. Price and R.M. Walker was popularized this field. They extended the development of this method by transforming the radiation damaged steel into the permanent tracks. In the present study, we use the 93 niobium ion in Makrofol-E detector to determine range. Range is an important parameter to understand the heavy ion interaction in matter. Due to high sensitivity of Makrofol-E and taking into account the accuracy of the measurements, the maximum achievable true take length of 93 niobium are taken as range. In the next slide, we can small animation of how text is formed in the detector. Now we come to the experimental detector. The Makrofol-E detector were exposed to a well-collimated beam of 93 niobium ion at exhaust channel of Unilag GSI Darmstadt, Germany. Energy variation is the 7.7 to 18.0 volt MeV per nucleon and incident angle is 45 degree. Here we can use the chemical etching process because chemical etching is so much important. The latest demonstrations are very thin and optical microscope cannot be used for their analysis. When we use open etching process is made to enlarge, develop and fix them. Here the irradiated Makrofol-E detector were etched in 6 NOH at constant temperature 60 degree and accuracy of the 0.5 degrees Celsius to develop nuclear tracks. For measurement of track parameter, we can use the camera-fitted optical microscope. For the projected track length, we can use 150x magnification and for the track diameter, we can use the 600x magnification. To determine the maximum achievable track length is calculated given by the equation Kekeripiri and Mukherjee. The first term is the true track length from the projected track length and second term is the surface etching correction and third term is the over etching correction. Here LD is the projected track length and phi is the angle of irradiation and Pg is the bulk state defined as the radius by time and is the T is the complete etchings. In the experimental details, we can see in our check the validity of the experimental range to check our some code we use. This is the one code is the Serum 2030 and one code is the DEDXT and one code is the list plus plus 0 Hubert ETO and one code is the list plus 1 minus Ziegler ETO and one code is the list plus plus 2 minus Atima 1.2 LS theory and one code is the list plus plus 3 minus Atima 1.2 without LS theory. The energy is variation is the 18.04 to the 7.7. We can measure the average value of sum of square. Here the lowest value of the sum of square is the Hubert ETL. It is the 4.84 and the highest is the DEDXT. It is the 7.37. In this graph we can see this is the black one. It is our experimental result with the error bar and the red line is the Hubert ETL. It is a very good agreement with our experimental results in these studies. From the conclusion, we can say the experimental value of 93 niobium ion range in Makrofol-E detector are good agreement in the Hubert ETO. We can also see that in percentage division in figure 2. And you can see we can measure the projected track length and we can measure the track diameter when we this is the overreaching the TB is the rounded and we can use the some references, and we can acknowledge the Professor KK Dwivedi, Vice Chancellor ITM University Gwalior. Thank you all.